Hey guys, how's it going? Today's video is going to be going over the different types of networking that you can achieve with Quick Emulator. So the first one we're going to start with is going to be user networking. This one actually kicks in by default if you don't specify any networking arguments in Quick Emulator. And the way it works is it's basically slurp, which is an old way of doing basically a shell to essentially forward all the information needed to set up a network. It has a lot of overhead, so it's generally not recommended. And yeah, let's dive into that. So I'm gonna go ahead and start up the emulator with no arguments, and we'll see here that it's gonna have networking, but it essentially will just behave as, like I said, it's gonna be using Slurp under the hood, so it's not gonna have a actual an IP based on the DHCP of your router. Instead, what happens is a virtual DHCP server gets set up and a DHCP client gets set up for you behind the scenes, and also a DNS server as well. So once we get in here, we're going to have our own IP based on the default settings. You can actually specify different arguments with the net user arguments. You can specify if you want a different IP configuration for your DHCP or if you want a different gateway. It's pretty configurable if you want to be able to do any of that stuff out of the box. So let's see, we'll log in here, and right away you can see that we do have networking. That's what this symbol is right here. If I click it, then I can see, oh, wired is connected. So that's the basic one. If I go to terminal here, oh, and let me tell you guys a shortcut here. So if you press Control Alt G, you can grab access for Quick Emulator, which will give you, well, essentially allow you to do shortcuts inside Quick Emulator, like the super user key. So if I press the Windows key right now, then it'll actually work within the emulator itself. If I didn't have grab, then if I press the super user key, my host Windows menu would actually pop up instead. So you can see here, if I type in IP address or IPADDR, either one will work, you will see that I do have an IP address right here, 10.02.15, and you'll see that obviously we can access the internet. So if I go here into Firefox, and you'll see there's nothing here saying, oh, we can't access the internet, please try again or something like that. It's not going to say that. I can access Google, no issues, just works just fine. The only downside to, well, one of the downsides I should say to user networking is that you don't have access to ping. So if I want to ping google.com, this is not going to work. The ICMP feature does not work at all with user networking. This will eventually just time out, so I'm just going to go ahead and end it. See, 100% packet loss. Doesn't work at all. But, I mean, it works out of the box, right? That's the great thing about Quick Emulator. I mean, even with VirtualBox, you can get it to work out of the box. But I think typically the default VirtualBox networking actually is a bridge network, if I remember correctly. It's been a while since I've used VirtualBox. But, yeah, I mean, this does work just fine, and you can use this if you want. Just keep in mind the overhead for this is a lot more than having like a network set up. I mean, typically if you think about it, the Slurp network that's being set up behind the scenes anyway is a network, but it's an internal network, so it doesn't actually have access to the outside world. Like I said, it doesn't have the, well, I mean, it has access to the outside world, but it doesn't have access to the host machine's network, essentially. So a couple things we can do though, like let's say we wanted to use this user network and we wanted to set up a web server on here. So let me go ahead and install Apache 2, which is the HTTP web server. If I go ahead and install that, we'll have a web server running here on our Linux distribution. So if we wanted to serve some website, then we could easily do it, or you can even set up an FTP server on here if you wanted to as well. It supports both of those. User network supports both. But so out of the box, let's see here. We have our Apache server is up and running. We can already access it. We just need to hit the IP. And yeah, so here's our Apache web server. You can see it's serving the default page here. And it's letting you know that, hey, it works. You're good to go. Let's say that I actually wanted to hit that web server from the outside world or even my host computer. You won't be able to do that out of the box just because, like I said, it's a user-based network and it doesn't really see it on the network. So if I do this, right, this IP is valid, but it's not going to find the server at all. It's just going to sit here trying to connect for a good while and it's never going to actually connect. So if you want to actually be able to access the server from within your VM, you can easily do that through the arguments in Qemu. So I'm gonna go over that real quick here. And you can achieve this with any kind of network connection. So the one for user, we're gonna go ahead and I'm gonna show you that right now. So if I say network interface or network interface card, it's gonna be user. I'm gonna say I want to forward the 80 port so that I can actually have access to the web server running on there. So if I do this, it's going to say, okay, on the host forwarding for TCP on the loopback interface, go ahead and add port 80 as a port forward, and port 80 as well for the VM is inside for the actual VM itself. So now that we have that set up here on the arguments, we'll be able to actually access it on the host. And the command I did, go over it real quick here. It's NIC is for network interface card. We're saying user. Like I said, default is already user, but since we're going to override it a little bit, we need to specify again that, hey, it's a user network. And the host forward argument is just saying you can do different protocols. So if you wanted to do UDP for like multicast or something like that, you could do that as well. But since a web server is hosted over TCP, we just need TCP, and this is the IP of the host computer. You could actually use your internal IP that's provided to you by the DHCP server running on your host if you wanted to. That's not really necessary. Typically, when you set up your computer, you already have loopback in your host file, so you won't need to worry about putting that IP. But if you wanted to, you could. You could definitely put your 192 or your 10.0 or whatever IP setup that you have on your host computer. You could use that instead of this. And then this is going to be your host port forward. So if I want to forward a different port, so let's say if I ran the web server on like port 8080 instead, you could just change this to 8080 and then internally I mean, it doesn't really matter. You can typically put this to any port you want. So if I wanted to do 1234 and actually hit 1234 on my host computer, it'll route it to the whatever port you specify here on the virtual machines, which by default, Apache web server is going to run on port 80. So that's pretty much how that works. It's fairly simple to do, and yeah, let's test out, right? So now that we're in our VM, go ahead and log in here. We'll just verify that we can still connect to the web server. It should still run. It should set it up as a service by default. And let's go ahead and make sure, yep, it does still work. We'll go ahead and maximize this. Oh, mouse is being, oh yeah, it's because I have grab on. So turn off grab, maximize the window, and turn grab back on. Oops, that's full screen. Another shortcut is Control Alt F if you want to go full screen. But yeah, so we still have the server running. So now that we have that forwarding, let's go ahead and try to connect to it from the host. So now the thing is that since I said I'm gonna actually use the loopback interface, the way we're gonna end up connecting to it is by just going to localhost essentially. And there you have it. So you can tell it's definitely Ubuntu. So it's actually getting forwarded into the virtual machine's web server, and that's pretty much it. So now you have access to your web server running into your virtual machine. But yeah, I mean, that's pretty much it for user setup. The next one I'm going to be going over is the tap network. And in order to do that one, if you're on Windows, first off, you need to install OpenVPN. So you'll go to OpenVPN and you'll go ahead and download OpenVPN and install that. And kind of like I said in the first quick emulator video, once you do that, what will happen is you will get a new adapter installed. Not that. A new adapter installed here called Tap Windows Adapter version 9 for OpenVPN Connect. And this is what we'll be using to be able to actually set up the NAP network, or TAP network essentially. It's going to use a TAP driver, but it's basically going to be setting up a NAT network. And once you have that set up, we just need to point to it. So that's kind of what I went over in the first video, but so since now that we have that installed, there's a couple other things we'll need to test out just to make sure, and there's one other thing we'll have to do as well to actually get it to be able to work. And you're going to want to come in here and go to properties, and from within here you're going to go to the Internet Protocol version 4, hit properties. Make sure you turn this to obtain IP address automatically and DNS server automatically, because by default it'll have a different setup here. And once you do that and have everything being automatic here, you're going to be good to go. Hit OK, close that, and then the last thing you'll need to do is you'll need to come here to your actual connection, whether it's Wi-Fi or Ethernet. Click properties and go to sharing, and you need to actually allow this to share with that same named virtual tap adapter. Since mine named local area connection, I'm going to share that with local area connection and hit OK. And so now that that's shared, once we launch the VM here and point to that one, which let me go over the arguments for that. That's going to be your NIC argument here. This time around, you're going to say it's a tap network, and you're going to say the interface name is equal to whatever you name it here. You don't have to name it or keep it as local area connection. You can change it to anything you want, but the name here has to match the name here. So since mine is local area connection, that's what mine is set to. So I'm going to go ahead and launch that. And you can see right away it's already got a connection established. So once we load into our virtual machine here, we'll have internet access. And it's that simple. It's very straightforward. Doesn't require a lot of setup or extra arguments or any, configuration changes within the virtual machine or anything like that. And that's pretty standard as far as like any distribution goes. Keep in mind, if you're doing a more a non desktop environment based Linux distribution, you'll probably have to set up a network manager so that I can be able to make use of or essentially so that I can set up a network service for you to run. You need to install a network manager and set up the network service to continually run every time you launch the computer. That way, whenever the computer launches, essentially what's going to happen is once you set that up, you'll have a network interfaces configuration, and inside that configuration, it's going to know how to actually connect to the internet. But yeah, if you're doing that way, then just keep that in mind. And you'll see here we're already on the internet, and we have a tap network set up, and fairly straightforward. Now, if I wanted to see what my IP address is, I'll go ahead and do grab on that, open up terminal, do IP address, and you'll see actually I have a 192 based IP this time around. Again, you can change that or change it to have a IP more based on the same IP assigned IP set that you have on the host computer. You could do that, and it'll actually pull that. And so, yeah, that's pretty much it. We have our tap network set up, and we're good to go. Now, the way the tap network works essentially is kind of like a host-only connection. Like if you compare it to like how VirtualBox has a host-only type of setting you can do. So essentially, your packets are getting routed through the host interface. So at the end of the day, you won't necessarily see this IP show up on the DHCP or on your devices list on the host or on the router, I should say. But what this will achieve, you can actually sniff the packets going through. So if you wanted to actually see what was going on from the virtual machine, and like I mentioned a little bit, or as I mentioned in the previous video, um, if anybody was able to penetrate your network, they could actually see what's going on in your virtual machine because they could just set up a packet sniffer and they'll see the packets coming from the virtual machine to the host. So just keep that in mind. I mean, this is the better option to go with as far as performance and network overhead, but you will have that risk. Just keep that in mind. But yeah, I mean that's pretty much the two most used network setups that you can have. You can also do a bridge network, but that's a bit more advanced, and Windows doesn't really have very good support for that. If you wanted to do a bridge network on Windows itself, what will end up happening is that you'll lose access to the internet on your host because once you bridge your Ethernet on Windows, it essentially turns off the network. It's the same thing as with a router. So if you wanted to run like, uh, so let's say you have your I don't know, whoever ISP you have, like Comcast is what I have, right? So let's say I have my Comcast modem slash router, dual purpose uh, device essentially, and I have my own router also, but I don't want to use the one provided by Comcast. I want to use mine, right? So the way to achieve that is you can't set up both. You can't connect them both and be just expected to work out of the box. It's not gonna work. That's just not how it works, right? A router has to have one input for the internet, or essentially for the actual internet access. Yeah. So what you end up having to do is you end up having to make the Comcast, modem slash router be a bridge instead, and it ends up bridging over the responsibilities and giving that to the main device that you're going to be connecting it to. So from that Comcast modem slash router, I'm bridging that over to my actual router, and from there my router takes over. But the Comcast modem slash router no longer, you couldn't like connect up other devices to it and expect that to actually have an IP assigned to it, since those responsibilities are no longer there as a bridge. So it's the same concept as in Windows. If you wanted to do a bridge in Windows, your internet access on the host is just gone. So kind of defeats the purpose a bit. I wish it was more like Linux, where you can actually set up a bridge and have access on the host at the same time. Uh, but you cannot do that on Windows, unfortunately. I've tried it. I've tried to set up multiple virtual network interfaces or adapters slash interfaces, whatever you want to call them, and it just doesn't work. Windows at the end of the day, you kind of have to cheese it anyway just to be able to set up multiple virtual interfaces on Windows. And at the end of the day, even if you try to like trick it by assigning the same IP to the virtual interfaces to the bridge, it's still gonna not work. I've tried every little workaround I could think of, but yeah, it just does not work. So those are definitely the most popular ones as far as like networking goes. Um, you can actually have multiple Quick Emulator virtual machines running and use the tap network at the same time, but you cannot with the user mode network since obviously it's internal. Just keep that in mind. Obviously, the bridge would probably be the better way to go anyway if you're trying to do something like that. And what you can do that. You can achieve that as well, even with Windows. You can try to set up the bridge kind of like a daisy chain a bridge. You can have your host, but keep your host not a bridge, and then have your first VM in the list be the bridge, kind of, and have access to the internet. So that's one way of doing it. But as it stands, Windows itself will just not support having a bridge connection and being able to access the internet unless you do have a second dedicated second dedicated network card. If you have a second dedicated network card, then you can actually achieve that. And the way to achieve that would be to set up a uh, virtual network interface through Hyper-V, and basically you assign one IP. You assign one IP to one of the interfaces and another IP to the other interface, and then you use the second interface to actually access the internet. And you can bridge the first one with your Ethernet. But you keep in mind you need to have both network cards plugged into to actually be able to achieve that. But yeah, that's the only way you can really achieve that on Windows right now. Maybe in the future they'll actually add support, but as it stands right now, it just doesn't work with one network card. So you're not going to be able to achieve that kind of setup. But yeah, it's been fun actually learning how to do this and setting it all up and messing around with it. But that's pretty much it, guys. So if you have any questions, let me know in the comments below. And thanks for watching. We'll catch you guys in the next video.